Good morning and welcome to this talk, Novel Pedagogical Approaches Using Jupyter Hub at Berkeley. So, just a sec. Great. I'm Balaji Alvar. I'm the service lead for Jupyter Hub at Berkeley. I'm part of research, teaching and learning and data science undergraduate studies. And I have my colleague Eric Van Dusen, who's the tech and outreach lead from data science undergraduate studies, who prepared this talk with me but couldn't be present today due to a schedule conflict. So I just want to take a moment to highlight how our work connects to the UC Tech team. The infrastructure we are working on is resilient in the sense it has been used asynchronously during the pandemic and during the strike at scale. And it's constantly rising as we are constantly working with new faculty who are working on new ideas, and we are constantly incorporating those ideas and improving the notebook experience. And it's re-inspired in the sense we are constantly have to make changes to the infrastructure to meet the rising needs of the faculty. Okay, so let's start with a short poll. There is QR code. If you can scan it, and the poll EV web URL is pollev.com/BALWAR490. Okay, I just want to get a sense of like, what do you want to learn from this talk? Just to see whether I'm covering that in this talk, and if not, if I have some time, maybe I can talk about it at the end. Overview of Data Hub, that's great. I think I'll be going through that. How Berkeley uses Jupyter Hub in education, sounds good. Outreach strategies to get more instructors on board. Yeah, I'll be definitely walking through that. Training for more expert instructors. Yeah, I think I won't be completely covering that. Maybe at the end of the conversation, if we have some time, I'll go over that. Okay, that's great. Thank you so much. That's helpful. So I just want to highlight the objectives of this talk. The primary objective is share insights from Jupyter Hub deployment at Berkeley, describe its impact on instructor pedagogy, and use some models to describe its adoption at Berkeley. Okay, so at another poll, I just want to understand the experience of the audience. Like, in general, how familiar are you with Jupyter notebooks? Okay, that's great. So we have a good distribution of folks who have used notebooks, and there are some of you who haven't used notebooks. That's great. Another question, how familiar are you with Jupyter Hub in general? Okay, it's a split. Like, some of you has used Jupyter Hub, some of you have not used Jupyter Hub, so that's great. That's really helpful. So I just want to start with a short activity for some of you who haven't say, used a Jupyter Hub or launched a Jupyter Notebook, I just want to show how that looks like and what that experience feels like. So we are going to explore the economics of supply concept, a Jupyter Notebook that is used as part of this class. And I'm just going to show you how that experience looks like. So what you are seeing is a notebook from the class Economic Models taught by Eric Van Dusen. Here, what the instructor is trying to do is basically model the supply of commodities based on the price and the quantity in a local market. You can see this experience where in the Jupyter Notebook at the top, you have the place where students write code and they execute the code. And below you can see the annotations where the instructor creates the narrative text that the students will use to understand the context of that particular notebook. And as you go down, you have output cell with a table or a graph, which when students execute the code, they will be able to see the outputs. And as you can see here the instructor is trying to make the students understand how the availability, the quantity and the price is correlated with the supply of commodities here. So that's just a short overview of how a Jupyter Notebook looks like for those who don't have an experience before. Now let's go back to the slides. As I said, it's taught by Eric Van Dusen. Okay, so I just want to talk about what just happened when a link was clicked, which launched this notebook. So a Jupyter Notebook was launched in one of the 15 plus instructional hubs at Berkeley. And these notebooks are hosted in GitHub repositories. Most of the time, these are public repositories where different instructors store all their curricular materials. And this unique link that when it got clicked, that launched the Jupyter Notebook in a Jupyter Hub is called NB Git Puller. It's a short form for Notebook Git Puller. And basically that allows for the notebook to be, a unique notebook to be loaded in the user's file server in Jupyter Hub. Now I just want to break down some of the concepts that I was just talking about. So what is a Jupyter Notebook? So Jupyter Notebook is an open source web server that allows users to create and share documents that contain live code, equations, visualizations, and narrative text, as I showed you before in the demo. Jupyter Hub is a multi-user server for Jupyter Notebooks, and it's hosted in a cloud server. And we use GitHub for hosting all the curricular materials, and it allows for version control using Git. And finally, NB Git Puller, as I talked about, is that unique link that links Jupyter Hub with the GitHub repositories. So just want to talk about the scope and scale of what is happening at Berkeley. So Jupyter Notebooks are acting as a pedagogical tool for many data science classes and many classes from diverse disciplines, for example, political science, demography, ethnic studies, economics, etc. And it also helps instructors innovate pedagogically at scale. So we have a doctoral class which has 8 students, and we also have an intro to data science class which has 2,000 students. So it caters to a diverse range of population. And just talking about some high-level metrics here, you can see our graph which highlights the usage. We generally have close to 4,000 to 5,000 users on an average during a semester. And as you can see, the usage drops off at the end of the semester and is generally high during weeks and lower during the weekends. And we have almost during a peak day, we have more than 1,000 plus students logging into Jupyter Hub to launch their notebooks and working on their assignments. And I also want to highlight the impact on teaching and learning. It acts, so the Jupyter Notebook, Jupyter Hub environment allows the instructors to customize the learning environment for students. The instructors could create quizzes, could create textbook, could create assignments, homeworks, etc., using the notebook experience. And it provides active learning environment where the students are actively engaged in the classroom setting as they work through the notebooks. And it provides powerful tools for data exploration and data visualization. So now I just want to talk about some of the use cases where Jupyter Hubs have been used at Berkeley. I just want to call out a engineering use case where we are looking at a civil engineering class called City Planning 88. Here this visualization is from an output from a student project. And just to give some context about this particular class, here the instructor wanted the students to analyze the electric vehicle stations in Southern California and find correlation between the per capita income and the population density. And instead of just previously I think the class was using MATLAB and they were doing some kind of analysis. And for this particular assignment, if I think about it, they were just looking at the data and they weren't doing any sort of analysis. But what they did after the Jupyter Hub introduction was that the students did a project where they analyzed the correlation between these variables and found that the population, the places where the EVs were lowly concentrated had high population density and lower per capita income. And their outcome, the output they wanted to highlight was that it was inequitable distribution of EV stations. I also want to highlight another use case from a natural science class. We have environmental science and policy management class where the instructor wanted to analyze the oak species across California. And they wanted students to look at different data sets and just see whether the data matches across different data sets. So what they did here was that they looked for herbarium APIs and they were looking for oak species in those data. And they were trying to map that with the museum APIs. And students worked on a project like a lab assignment where they matched these data and saw how that looked like and formed their own interpretation based on that. I also want to bring out an ethnic studies class notebook where the students were exploring prison realignment programs in US. Here you can see a widget that the instructor created using Jupyter Notebook experience where the students were looking at occupation of prisons across multiple institutions in California and how the occupancy looked across multiple decades. And they were also exploring, is there a gender angle to this concentration and so on. So they were exploring multiple questions using this particular notebook. So now these are some of the examples from 100+ notebooks deployed at Berkeley. I just want to highlight how the outreach and pedagogical support that we do at Berkeley that makes it possible. So the first is departmental outreach. The way we work is that we reach out to the departmental head of a particular department and just share the vision of what we want to do with what we are offering and what is the vision for the classes in terms of active learning and so on. And we also do we do a proper onboarding with the instructors where we try to understand what their strengths are and what are the ideas they have for the class and how a Jupyter Notebook, Jupyter Hub experience would look like for them. We also have student teams named modules. They primarily work with instructors to create these Jupyter Notebooks. And in cases where Jupyter Notebooks are already existing in the classrooms, they work with the instructors to improve the notebook experience. So if we want to deploy a new notebook in a classroom in spring 24, we reach out to the instructor during fall 24, and the modules team works with the instructor during the semester to build these notebooks, and they get deployed the subsequent semester. And they get constant feedback throughout the semester and keep improving the notebooks. And their support is really important, because if when we thought about going to a lot of social science classes and humanities classes, the instructors didn't have time or sometimes expertise to build these notebooks, and their expertise was really helpful for them. And finally, we have an open source documentation which provides support for instructors. It's called Curriculum Guide, and they just use that to understand curriculum related questions and technology related questions. We also have inputs on troubleshooting issues, the common issues that other instructors face. Now, I just want to take a moment to talk about some instructor personas that we observed during our experience at Berkeley over the last 5 to 6 years. So we have seen 4 different types of instructor personas. The first one is an innovator. The second one is an advanced user. The third one is an intermediate user, and the last one is high touch users. I'll share in detail how are we classifying this instructors into these personas. Primarily, the key characteristics of the instructors that I want to highlight are the innovators. So the key characteristics are their programming language proficiency. Are they good with Python programming language, or R programming language, or Julia programming language? These are the languages that instructors use at Berkeley for their notebook-based work. And we also look at how familiar they are with Jupyter Hub and Anaconda and so on. And we also look for familiarity with data science tools like NB Git Puller, grading tool if they need it, and so on. So we found that most of the scenarios, the innovators are highly proficient across all these categories. They don't need, say, for example, a support from modules team. And advanced users also, they are more highly proficient. They may not have good understanding of the data science teaching stack. They may need some support on that front. And intermediate users, they definitely need support from a programming language perspective, and also with just the basics of Anaconda, Jupyter Hub experience. And they definitely need support with data science teaching stack. And high touch users, we need to support them on all these, they need support on all these categories. Now, what do we do in terms of support for these types of instructors? So we do 3 forms of support. One is the effort involved to initially onboard an instructor, and then the constant updates to documentation that enables the instructors to make updates to the infra. And the last one is the one-on-one support during the semester. So I just want to highlight that innovators require the least amount of support. We just do the initial onboarding, and then we just keep updating the documentation, and that's good enough for them. They don't come back to us after that. Maybe they may come back to us with a niche need, but other than that, they just go on. They just go on with their plan. With advanced users, we definitely need to put some effort to initially onboard them, and we need to keep updating the documentation, but we don't, once again, we don't need to support them at that regularly. But with intermediate users, that's where we definitely need to put a lot of effort in terms of initially onboarding them and ensuring that they are aligned with the vision. And they can work with the documentation, but they sometimes might need help that needs human intervention, so we reach out to them and support them. And finally, in terms of support needs, for certain scenarios, they may reach out to us, but for basic use cases, they should be perfectly fine. For high-touch user, we definitely need to have a proper onboarding, we need to have a regular support, and we don't expect them to work based on documentation. We are there to support them directly, as they may not have the bandwidth to look at documentation. So that's the instructor persona that we observed at Berkeley. And with that, I also want to highlight we were thinking like, is there any kind of a model by which we can map the growth at Berkeley and see what's the future looks like for us? And we saw that we found this interesting model called technology adoption lifecycle model. This particular model uh, was told by Everett Rogers in 1960s. Basically, he was trying to model the growth of a product, and his hypothesis is that we have initially the innovators who start using the product, and then we have early adopters, and then we go to early majority, and then late majority, and then we go to laggards. The x-axis here is the time, and y-axis here is the percentage of the population that is actually using a product. So we were thinking, like, is this relevant to us? Like, should we use this as a model to see where we are at Berkeley and where we want to go? And I just want to highlight that, once again, all models are wrong, some models are useful. This was coined by the statistician Box. So whatever we are saying are a bunch of hypotheses which we are validating. So we believe that we are at the early majority at Berkeley in terms of adoption. And the reason for that is that we think many of the non-data sciencey classes in different disciplines have started adopting these notebook experiences, and they have started using it. So that's one of the reasons for that. And also, I just want to highlight the gap between the early adopters and the early majority. You see a gap, and that's in 1990s. Jeffrey Moore coined the chasm theory, where he highlights that most products, when it moves from an early majority, from the early adopter stage to early majority, they have a breakdown. Like, many products don't reach the early majority stage because the user experience, the support experience, the onboarding experience that you created for the early adopters won't be the same, won't be relevant to the early majority. They might have a fundamentally different needs that you need to focus on. So most products die at that stage of adoption. And yeah, so that is a mental model we think about in terms of like looking at Jupyter Hub adoption. We feel that we have crossed the chasm, at least that's our belief. And in order for us to reach the next set of instructors, we see that if we don't do any support, we may not, the no support cases where the curve is the smallest, we may not even reach late majority or laggards, possibly. With outreach, we might have a better reach, but with a proper support channel, including onboarding and one-on-one support, we may reach more users in this curve. So I just wanted to highlight that as a mental model. And finally, I just want to end this talk with a summary of the key points. Jupyter Hub is used in diverse instructional contexts and is a powerful pedagogical tool. The level of onboarding and support required for instructors may vary depending on the discipline, depending on the instructor experience, so it needs to be factored. And adoption of Jupyter Hub is an iterative process. There is no one path that works well. There are cases where instructors have adopted notebooks, have gone back to their old approach, and they may come back later. So it's an iterative process, and it has to be handled that way. And yeah, just going back to some of the points, some of the key points you highlighted, you wanted to learn from this talk. I think I covered most of these points. In case if I'm not, like, you could ask me as part of the questions. Thank you. Thanks. Yeah, sure. Yeah, please.
Try. I guess it's on. Okay, student modules, the students who help instructors with their courses and with the materials. How do you train them? Do you have onboarding materials? Because what we find at UC San Diego and our Jupyter Hub, student employees don't get a lot of Docker and container training in their coursework, so we have to really onboard them. Any strategies that have worked for you?
Well, that's a great question. So the modules team's scope of work at Berkeley is limited to building these Jupyter notebooks and closely working with the instructor to iterate on it. They don't contribute to the SRE side of things in terms of the managing the Docker image, customizing the packages. Those are all handled by the infrastructure team, the backend team. So that we have made a clear separation that students from the modules team don't do this particular work. And I would be curious to learn from you, like how your experiences over the years in terms of training students.
So this is, I think, a follow-up question to that. When you onboard, when a new instructor wants to create like a space for materials for a new class, how much technical expertise, what's the minimum technical expertise they need to sort of get started to like create those materials and get them, test them, get them deployed, whether, and at the other end, sort of how for your innovator instructors, like what's sort of the maximum level of access and customization you allow them to have in your environment? Like what do the instructors need to know and what do you keep as your own responsibility?
That's a great question. So in terms of when we try to onboard an instructor, at least in my opinion, the three things we look for is, do they have experience, can they learn GitHub? Are they open-minded enough to work with GitHub, upload their curricular materials, make it public? So that's the first one. The second one we are thinking about is like, are they open enough to fiddle with NB Git puller, like generating that unique link? And are they okay with that? Can they get some TAs in case they are not interested? Can they get some TAs who can support them with that? And finally, are they open enough to look at Jupyter notebooks, like Explore notebooks, Explore visualizations, and so on? The main thing what we have found has been really helpful is having a technical TA, a technical teaching assistant, who can be the person who onboards the next technical teaching assistant per se. So for some of these large classes, they have their own technical person who handles the infra related stuff. For data 8, which is a 2000 student class, they have their own technical GSI. But in smaller classes, we really ask the instructor to get a GSI who's willing to get into the weeds of the different technologies, who is willing to explore stuff. And they update the next GSI and they do it, and it goes like a chain. In terms of the upper limit, I think the way, at least it has worked at Berkeley, is that we give a lot of latitude for instructors. For example, Fernando Perez, the Jupyter founder, like his classes need a lot of stuff. Like they need Git authentication within Jupyter Hub. They need customized Docker image. They need Linux desktop environment. Sometimes they need Postgres database. So I think we have mostly been able to support his classes, support his needs. But I'm saying like the needs, the amount of latitude the instructors have here is really high.
So I have a two-part question in a sense. So you talked about these different levels of instructors where you have the innovators and advanced and intermediate and the beginner or whatever you call them. Can you comment just on what the specific numbers are as far as distribution of instructors among those categories? And also for the ones who are more at the beginner level, where I assume that they might not be able to support the programming needs of their students quite as well as the advanced users. How do you or how do the instructors accommodate students who come in with a whole variety of different programming backgrounds into the classes and use the notebooks?
That's a great question. I think in terms of distribution, I would say the innovators would be like 1 or 2%, like 2 or 3 instructors, I would say, as innovators constantly pushing the needle. And advanced users, I would say, like I've seen like a lot of these data science classes have a lot of advanced instructors constantly tinkering with new stuff, but not as much as you would categorize them as innovators. And intermediate users, I would say at least 20, like a good chunk, like a 40% of instructors would fall into the intermediate users, 40 to 60, I think majority of them would fall into that intermediate users, I would say. And the last 20%, I would say they are falling into the high touch users. And once again, this is with the bias that this sample is based on whoever who have adopted Jupyter notebooks in their classroom. Once again, if you account for the people who haven't adopted, the distribution might be completely different. And what was your second question? Sorry.
Yeah, thanks for that answer. The second part was just how do you accommodating the programming needs of the students when the instructors are more at that medium or high touch case? That's
a great question. I think some of these classes, they have lab sessions where the GSIs, or the teaching assistant generally work with the students on programming related stuff. And in certain classes, for example, the ethnic studies class, here the core output the instructor is looking for is understanding the concept. They're not looking at students to gain a lot of technical expertise over, say, Python, R, or Julia. So here they are just looking at them, exploring the notebook, running the code, looking at the visualization, making interpretations. So in those cases, the instructors are perfectly fine with their pedagogical approach where students are not learning anything about programming because that's not core. But in cases where the instructor wants the students to learn, they lean on their GSIs who have experience with Python, who have experience with R, and so on. And the way we train in them is that D-Lab D-Lab at Berkeley conducts a lot of these data science workshops. I think some of these GSIs attend these workshops and they get trained their Python skills, trained their R skills. So that also helps them. And we also generally connect them with modules team. The modules team works with the GSIs. They also train them in case if they need basic Python help, say they don't understand pandas or Cbon or matplotlib, those packages, they help them with those basic stuff. So yeah, so that's the approach that generally happens here, I would say.
Could you say a little bit about how Jupyter Notebooks or Jupyter Hub can or is being used for group work and whether that requires any additional technology?
That's a great question. In general, many group projects, many of these classes require group projects. And right now, the way it has been working as is that students just collaborate on the Jupyter notebook. They code, one person writes the code, the other person verifies it, and so on. So they are students are figuring out their varied strategies. But we really wanted to get real-time collaboration functionality as part of these Jupyter notebooks, where students are looking at notebooks and working as if it is like a Google Docs setting. So we did a pilot with Fernando Perez's class this semester where he adopted real-time collaboration functionality. And our experience has been that it's not yet ready for full-time, for adoption at a mass scale. The reason being is that there were data corruption issues that we identified. There were security issues that we identified. We also, since this work involved close collaboration with the open source developers, we filed upstream issues. In certain cases, we also filed PRs, just updating about these issues and also pitching in with the solutions. So I think in terms of group projects, we really want to have a proper real-time collaboration environment. And we are thinking about finding other instructors who are willing to pilot this use case, because Fernando will be on a sabbatical for some period. So that's where we are. And I have heard from DeepNote folks that there are 13,000 students at Berkeley who have registered with DeepNote, and DeepNote has real-time collaboration. So my hypothesis is that maybe students are using DeepNote just for these live projects per se.
You talked about some instructors are using notebooks to introduce concepts, so it's not really programming. Do Jupyter notebooks have interactive abilities for things like quizzes, or you write an answer and it goes to the instructor, or is that different?
Yeah, my understanding is that some of these instructors use jQuiz, if I'm not wrong, or I might be not saying the package rightly, but they use packages like jQuiz, and they create these interactive quizzes for students to work on. And yeah, I would say like instructors create simulations. I've seen a lot of simulations, quizzes. I have seen dashboards. They have created Voila dashboards using Jupyter Hub, and they have created Plotly dashboards just to showcase certain stuff. Yeah, so, and they have also created textbook like Jupyter books to drive home certain concepts. So those are the things I have observed in terms of instructors creating new mediums to come in.
So another question, what do you see as, or do you see any instructors using Jupyter Book, or do you think something like Jupyter Lite is also a technology that's going to be incorporated into the classes?
Yeah, that's a great question. Jupyter Lite is something we, most of us at Berkeley strongly believe that it's going to be the future, at least for some of the classes. And right now, I think no instructor is using Jupyter Lite as is. And primarily, most of the innovators, like the advanced users here, have auto graders as part of their use case. So Jupyter Lite doesn't neatly support auto graders. And as a result, it still is not at a stage where people are experimenting. But I guess my colleague Eric is working on updating his Jupyter notebooks, trying to pilot Jupyter Lite as part of his class, and he's trying to see if auto graders map neatly with Jupyter Lite. So that's where things are with Jupyter Lite. Jupyter books are extensively used. I've seen a material science instructor who created a Jupyter book as part of their workshop, and I've seen all the intro data science classes, Data 8, Data 100, they have their own Jupyter book, if I'm not wrong. And I would say, once again, Jupyter book, still, my hypothesis is the adoption is still in the advanced users and innovators. That's it. I haven't seen any, say, a social science class have a Jupyter book per se. So that's my interpretation, I would say.
My question is, have you considered cloud-based platforms such as Azure ML Studio or Google Colab? And if so, why did you choose Jupyter Hub over one of those platforms?
That's a great question. So I think the decision was made before even I joined. So I can't talk for the exact decision that led to it. But one of the things I am understanding as part of this work is that a lot of instructors, like these innovators and advanced users, they want customized Docker images. They want to constantly update packages, new packages, their versions, or try out new packages. So that level of customization needs a Jupyter Hub kind of an environment with a team that is properly responsive and supportive of that process. So my hypothesis that might be one of the reasons for going down the Jupyter Hub route.
You've mentioned Docker a couple of times. Is Jupyter Hub built on Docker, or when does an instructor or their TA need to learn how to use Docker?
Once again, this is where I'm making a lot of points which are beyond my core competency. But my understanding is that like we have 15 plus instructional hubs at Berkeley, and each hub, Jupyter Hub, has its own Docker image. And the Docker image lists all the packages that the instructor or the hub needs for a particular hub. So, for example, like we have these the main data hub, which has the basic data science packages like matplotlib or Seaborn or pandas, and there is a data science package that is created for just Berkeley. And there are other hubs like Biology Hub that has like biology specific, genomic specific packages. And there is Public Health Hub, which has, like in the Docker image, has the public health specific packages. And they focus a lot on R based workflow, and they have RStudio. So all the Docker image is customized for the R environment, I would say. So yeah, so that's how it works at Berkeley. And did I answer your question?
Thank you. On the topic of the languages being supported, what is the general distribution between Python, R, and Julia, and what are the trends that you're seeing?
So at least 80 to 90% of the classes, in my opinion, uses Python. Many social science classes, I would say, use R, but I would still put it as, say, 10 to 15% of the classes use R. Julia is used only by 2 classes, like a couple of, I think it's one, both these classes are from math department and focus on numerical methods, I guess. So Julia is very niche and it's not as regularly used, I would say. Mainly the distribution is 80% Python and 20% R.
Related to the languages, can you also comment just on the environments? So I believe you mentioned Fernando Perez needs a Linux desktop environment. And also, so Jupyter Hub can support RStudio, I know, in addition to the Jupyter environment. Are those the 3 main environments, or is there something else as well?
So I think the main ones are, as I said, Linux desktop environments. And we customize that based on the class needs. For example, a civil engineering class required QGIS, which is a geospatial application. And other than that, we have Postgres database and Mongo database that is needed for some classes. Then we customize the Conda environment because for certain biology classes, they needed a different Conda environment. They needed certain packages that required a different environment, so we customized that. Then we have shared read and shared read-write directories, which is used in classes like in some of these classes in biology where they have huge data sets running up to 40 gigs. So what the instructor does is that they update all the data sets in the shared directories. So it's a write only, it's a read write for instructors and read only for students. So students import the data. So we customize that. Then obviously auto graders, like ensuring that auto graders work well with Python based classes and R based classes. And then, yeah, I think those are the ones that comes to my mind right now.
Since you mentioned QGIS, I know a lot of GIS software requires GPUs. Is that provisioned, and does that cost you more money, or how does that work?
That's a great question. So I think that's a question that we get at least once every semester, I would say. Folks from Haas, they were running a program called Masters in Financial Engineering. They wanted GPUs as part of the notebook offering. Generally, we don't support because we don't already our cloud costs are like increasing, so we don't support GPUs as we don't want the cloud cost to skyrocket. Generally, what I have seen they have done is that they have used commercial solutions in that case, or I think Haas ran its own bare metal Jupyter Hub. So I think my sense is that it might solve for their needs.
One final question. Do you support anything as a software installation that requires a license?
That's a great question. I think almost all the softwares we install are open source, and we have had, so we wanted to install MATLAB at some point of time as part of Jupyter Hub, and we did not do that because MATLAB required license. And recently, Jupyter MATLAB package got released, and we were considering whether, like we were thinking whether we want to install Jupyter MATLAB. But yeah, so we were still not sure whether it is open source, whether it requires a license, so we didn't go with that approach. So yeah, so we generally install open source packages and softwares. Okay, that's great. Thank you so much. Thanks for the questions.